Hello all of you, I am Ms. Amrita Jadhav ma'am and I am going to present part 7 of electrostatics, and in part 7 we are going to deal with the new concept. Not exactly new, we have seen some basic parts about it in the previous lecture, and for today we are going to see that in detail. Alright, so before moving toward part 7, we are going to revise what we have done till now. So let's move. So here are some points which we have done in the last lecture. First point that we have covered is conductors and insulators, free charges and bound charges inside a conductor. Now we will discuss it in very short period, and then we'll go towards our today's lecture. Alright. Conductors and insulators. Conductors are the molecules or the substances which allows electricity to flow through it. It allows the electricity or the charges move from one place to another. That is nothing but conductor. Now what is insulator then? Insulators are the substances which do not allow the charges or electricity to pass through it. These are called insulator. We have seen some examples of conductors as well as insulators. Basically, metals, human and earth, or even animal bodies are used to be called as conductors, and insulator are nothing but glass, plastic, rubber, wood. Basically, these all are example of insulators, right? Then what is free charges and bound charges inside a conductor? When we consider a metal which is having a nucleus at the center and electrons around it, these electrons are always moving in certain orbit around the nucleus. There is a bonding between nucleus and that electron, right? When the material is conductor, the electrons which are there in the outer orbit, they will conduct from one orbit to the another orbit of another atom. That means they can move, they got free from the orbit. That's why it is called as free charges. And when we come into the consideration of insulators, the electrons which are there in the orbit are very closely bounded and very strongly bounded towards the nucleus. So whatever condition come across, these electrons will not get free from the orbit. So these are bound towards the nucleus. So these are called as bound charges. Alright. So basically free charges are for the conductors and bound charges are for the insulators. So this is the first point which we have done yesterday. Then the next point, which is dielectrics and electric polarization, also we have seen. What is basically dielectrics? Dielectrics are nothing but the insulators which can be used to store electrical energy. And why this is so? Because such materials or such substances are placed in external field, and their positive and negative charges are displaced in opposite directions, and molecules develop a net dipole moment. This is called as polarization. Now when we say dielectrics, in which we consider atom, again I am going to tell you the example of the same, which is the nucleus is at the center and electron will revolve around the nucleus, right? So the nucleus is having its own center of mass, and negatively charged electron will be having their own center of mass. Now due to coinciding or does not coinciding of the atom, we get the two type of dielectrics. The first type of dielectric is nothing but polar. What is polar dielectric? A molecule in which center of mass of positive charges does not coincide with center of mass of negative charges. But why this is so? Because there may be the asymmetry of shape of the molecule. So these are called as polar molecule. So which kind of molecule when comes in contact and having the asymmetric shape? We can say the example of HCl. Shape of H is different than shape of Cl, right? I can tell you the example of H2O. Shape of this 2H are same, but shape of O is different, so they cannot coincide with the centers of negative and positive charges. So these comes in polar dielectrics. So what happens to the dipole moment in that? So this kind of dielectrics are having very high dipole moment, and it is of the order of 10 to the power minus 30 coulomb. And then the second example which come forward, which is non-polar dielectrics. Now, as we have seen, when the center of mass does not coincide, we get polar molecule. So what will be non-polar? So a molecule in which center of mass of the positive charges coincide with center of mass of negative charges, it is called as non-polar. So why this may happen? Because the symmetry nature of the shape. Which kind of molecule may get interact with each other and coincide the centers? H2, H and H both are having same shape. Again, what we can say, O2, oxygen, both are having same shape, so they can coincide with each other. Centers are coinciding with each other. So what happens to the dipole moment over there? Dipole moment becomes 0. So in non-polar molecules, dipole moment is 0. So this is nothing but dielectrics, concept of dielectrics and the types of dielectrics. Now, what happens if we are giving external field to such kind of materials, to polar also and to non-polar also? What will happen? Let's see. So in this lecture we are going to learn the same points. That means polarization of non-polar dielectric in external electric field. When non-polar molecules does go in contact with the external field, what exactly happens over there? Does dipole moment create or decreases? Does the current flows through it? That we are going to see in this lecture. Again, the second one is polarization of polar dielectric in external field. These 2 points we are going to discuss, and even there is a third point, which is reduction of electric field due to polarization. When polarization happens, what happens to the electric field? Does it get decreased or it get increased? So the answer is there is reduction of electric field due to polarization. But how? That we are going to see. Okay, so let's move towards first point. One by one we are going to deal with all the points. So here is the first point, in which we are going to see polarization of non-polar dielectric in an external electric field. Okay, now before moving towards this point, let us again revise. What is non-polar? Non-polar are the molecules in which centers of mass of positive nuclei coincide with center of mass of negative nuclei. So the dipole moment gets 0. Dipole moment is not there in non-polar. This is the basic concept of non-polar molecule, right? But now we are going to give a external electric field to non-polar molecule, and let's see what happens to that. So in the presence of external electric field E0, it has been denoted by E0, and the centers. Now what happens exactly? See, when we are going to apply a electric field to non-polar dielectric, the negative and positive charges are try to pull from each other. That means they are displacing from one another. So when they got displaced, the positive and negative charge will get displaced from one another. They will get separated by some distance. So what this gives you? This gives you dipole. because what is the definition of dipole? When equal and opposite charges separated by some distance, we are getting dipole moment. So when external field is applied, the centers of positive charges in each molecule of nonpolar is pulled in the direction of E0. It got pulled towards E0, while center of negative charges. Now what is center of negative charges? That means electrons are displaced in the opposite direction. Nucleus is moving towards E0 and electrons is moving away from the E0. It is in opposite direction. So therefore two centers are separated and molecule get distorted. Okay, molecule get distorted. The displacement of charges stops. When it can be stopped? When we say the external force which is applied to the non-polar molecule is being balanced by the restoring force between the oppositely charged electrons. Again I will explain. When we are considering an atom, it is neutral. Why we are saying it is neutral? Because all the negative charges are being balanced by the positive charge which is at the nucleus. So the net charge of an atom is what? 0, because they get balanced. Now if this charge of an atom gets balanced by the external electric field, then only the displacement will get stopped. But when the external field goes on increases and its strength goes on increases, then the restoring force between the oppositely charged atoms, they got pulled towards the electric field that we have seen, and the centers get separated. When it happens? When the strength of external field is highest than the restoring force. But when these both get balanced, this displacement will stop. Okay, and each molecule becomes a tiny dipole having a dipole moment as the external field is continuing to the nonpolar dielectric. So each molecule will be having a tiny dipole moment. Why this is? Because they get separated, and the induced dipole moment of different molecules will get added up. Alright, so each molecule is having dipole moment, so we have to, it get induced, it created, it was not there because it is non-polar molecule, so dipole moment was actually 0. But when we apply external field, the dipole moment is being created. So we are saying the induced dipole moments of different molecules will be added up and giving a net dipole moment to the dielectric. But when it is so? In the presence of external field only. When external field is applied, then and only then this can happen. Okay, I hope this is clear. Let's see the diagram for this. Here are the diagram. First diagram is showing dipoles, non-polar molecule, non-polar dielectrics when electric field is not there. See here, they are pairing up, they are coincided because plus and minus is in one circle only, so they coincide with each other. So this is non-polar, right? And the second one is when electric field is given to it, this started to separate as they were in a single circle, plus minus. When external field is given to it, it gets started to separate, and when they get started to separate, they are giving dipole moments, and this is having some dipole moment, this is having some, so all of them having some dipole moment in certain direction, so the net will be add up of all of this. So this we have seen. Okay, let's see the second point, which is polarization of polar dielectric in an external electric field. Now, what is polar dielectric? What is polar dielectric? The molecules in which center of positive charge do not coincide with center of negative charge, and there is a net dipole moment for the polar dielectric. Okay, there is a net dipole moment. But what happens when we are giving some external field to it? There will be production of thermal energy, right? When thermal energy goes towards this polar dielectrics, these all molecule will give you such kind of movement. So according to this, the total dipole moment will become 0. I will explain it again. As we have seen in polar dielectrics, they have permanent dipole moment, right? But due to thermal agitation in material, in the absence of any electric field, when electric field is not there but thermal relation is there, thermal activity happens over there in the absence of external field, these dipole moments, what you can see over in this diagram, all dipole moments are randomly moving, right? You can see the previous diagram in which all are aligned, but here you can see these are randomly moving. As they are randomly moving, and due to the orientation, the dipole moment gets cancelled and it gets 0, right? So the first point tells us that the dipole moment is 0. Why we are getting 0? Due to thermal reaction. They get oriented in any direction, they are randomly moving, so we are getting dipole moment as 0. Now what happens when external field is applied? When external field is applied, again the moments of different molecules tend to align with the field. Here you can see these all are tend to aligned in the direction of the field. As a result, it develops a net dipole moment. As here it gets cancelled, but when external field is applied, we are getting dielectric or dipole moment again, and dielectric get polarized. Are you getting? When electric field is not there, due to the alignment and due to the thermal agitation, dipole moment becomes 0 for polar molecules. But when we are applying external field, all the non-polar molecules, non-polar dielectric, tend to align in the electric field and they produce some dipole moments. So we are getting some net dipole moment over here, and dielectric is get polarized. Hence the extent of polarization depends on the relative values of opposing energies. Alright, and there are some more points which we can discuss. The first point is the applied external field is tend to align the dipole with the field. Yes, when we are applying external field to polar molecule, they tend to align the dipole with the field. Thermal energy tending to randomize the alignment. We have seen in the first diagram. What does the thermal energy do? Due to the thermal energy, all the non-polar molecules are tending or aligning randomly inside a structure. But when we apply external field, they are in properly aligned in the direction of external field. So this is the main difference between them. Now the polarization in the presence of strong external field. When we are applying very strong external field, what happens exactly over there? Both polar and non-polar dielectric develop a net dipole moment. This is the first point. When strong external field is applied to polar as well as non-polar dielectric, both are giving us net dipole moment. This is the first thing. Okay, and the dipole moment per unit volume is called polarization. Very simple definition. The dipole moment per unit volume is called polarization, and it is denoted by capital P. And the formula for this is P is equal to chi. Sign is known as chi. Chi E into capital E. Now what is chi E? Chi E is the constant called electric susceptibility. This is nothing but constant of susceptibility. It describes the electrical behavior of a dielectric. It gives you the electrical behavior. So suffix E is there. Alright. And it has different values for different dielectrics. When we consider a dielectric, suppose glass, rubber, not rubber exactly, glass. So number of dielectrics are there. When we consider different dielectrics, chi E will be different. Now what happens for vacuum? For vacuum, chi E is 0. You have to remember this point. Chi E is always 0 for the vacuum. Okay, so this is all about polarization when external field is applied to polar as well as non-polar molecule. What we get, the single conclusion from all of this discussion: polar molecule as well as non-polar molecule gives us net dipole moment when external field is applied. This is the main conclusion of this, and we got the formula for P, which is chi E into capital E. Alright, so this is all about it. Now, as we have said in the very first, that what happens when polarization takes place? Does the electric field decreases or increases? So the answer is it decreases. How it get decreased? So let's see. We are going to consider a rectangular dielectric slab. Okay, we are going to consider a rectangular dielectric slab which is placed in uniform electric field, which is acting parallel to its faces. Okay, so since the electric charges are not free to move, why they are not free to move? We have said that, we have discussed that dielectric is nothing but insulator. So in case of insulator, bound charges are there, not free charges are there. So that's why, since electric charges are not free to move about in dielectric, no current will flow. Obviously, if the charges will goes on moving from one place to another place, then only current will flow through it, and then only we are getting a current. But as there are no free charges, current will not be there. But when it is placed in electric field, instead of moving the charges, the another thing happen in this. What can be happen? Obviously they will get aligned. So the electric field produces a slight rearrangement of the charges within the atom. Again I am explaining. If we are considering a dielectric slab, alright, and it is placed in an external field which is uniform. Since electric charges, we are saying dielectric. So dielectric is nothing but insulator. So there are no free electrons inside an insulator. They have bound charges in insulator. So as there is no free charges to move, current will not flow. So what is the role of external field then? So when external field is applied to dielectrics, the molecules will start to align themselves. They are not moving from one place to another. They are just going to align in smaller amount. Okay, and it is with respect to the field. So during the process of alignment, charges move only over the distances that are very less than atomic diameter. Atomic diameter is already very less, and they are moving in such a smaller space because they are dielectrics. So they are moving in very smaller amount, which is less than a atomic diameter. Alright. As a result of the alignment of dipole moment, there is apparent, what will happen when they aligned, there is apparent sheet of positive charges on the right side. All the positive charges will go to the right side and all the negative charges will shift towards the left side. They're trying to move. We can see in the diagram over here. We are having diagram. Alright, we are going to see that diagram here. Here, the first diagram we can see. In first diagram you can see when external field is applied. In all the cases we are going to say that external field is applied and which is uniform, and this is nothing but the dielectric slab in which you can see dipole moments are being created. Okay, and all the positive charges are get towards the left side and all the negative charges are along the right side. Now what will happen afterwards? These two shades of induced charges produce an electric field E0. As positive and negative are get separated on both the sides, what will happen over there? They can induce some charges on the surface, because here are the positive charges and here are the negative charges. You can see over here, here are the positive and here are the negative. So they are going to produce a charge on the surface. So that is nothing but E0, and that is known as polarization field. That creates a polarization field in an insulator which opposes the applied electric field, because the insulator is not going to free the electrons and they are not going to move. So they create all the charges on the surface itself. Charges will get there on the surface only, they are not going to move. So that is known as polarization field. Now the net field will be E dash if we are considering, and inside the dielectric is the vector sum of applied field E and polarization E0. Obviously we are going to say E dash is net dipole moment, E is the external electric field which is applied to the dielectric slab, and E0 is the polarization field. So we are getting this as E dash is equal to E minus E0. So this is what we are getting. I hope you got all the point. Very easy to understand. As we have said that dielectrics are insulators, there are no free electrons, only bound charges are there. When we applied external field to that, they only isolate or they only take the charges on the surface. They do not move from one place to another. So what happens to the dipole moments? The molecules which are there inside it will only align. So here is the second diagram which shows that the induced surface charge on the dielectric establishes a polarization field E0 in the interior. So negative will get attracted towards the positive and positive is moving towards negative, and they are polarized. And after some time, this is the net field E dash is a vector sum of E and E0. Here is the answer of your question, which is how exactly it got polarized. So this is the example. All will move towards the attracted towards positive will go towards negative and negative will go towards positive. So this is it. So the conclusion from this, we can say the greater the applied field, greater is the degree of alignment of the dipoles, and hence greater is the polarization field. Obviously greater is the applied field, alignment will goes on increases. As the alignment will goes on increases, polarization field will increase. Okay, now I will tell you one example, or I will tell you one thing, which is if we apply a large enough electric field, we can ionize the atoms. and create a condition for electric charge to flow like conductor. Alright, what I am saying, if we apply large enough electric field, we can ionize the atom and create a condition where the bound charges are there for the insulator can free from that orbit, and the point or the field required for this to free that electron is known as dielectric strength. The strength at which the electrons from the insulator got free to conduct is known as dielectric strength. Okay, so this is all about polarization of polar as well as non-polar molecule. Okay, I hope you understood what I have taught you today. Alright, so this is all for today's lecture. I hope you have watched whole video. Thank you so much for watching. These are the points which we have learned today. First one is polarization of non-polar dielectric in external field, then polarization of polar dielectric in an external field. Polar and non-polar both we have seen. Then reduction, how it get reduced, that we have seen. These all points we have covered today. So this is all for today. Thank you so much, and we are going to arrange a live doubt clearing session. So please do email me. I have given email ID, so mail on that email ID for your doubt, which is up to point 205, which is capacitors in parallel. Up to that point we can cover tomorrow, so you can do clear your doubt up to that. Okay, thank you so much.